This online video lesson is about chemical and physical changes. In chemistry, we study matter and how it changes, and so it's useful for us to recognize that there are two main ways in which matter can change. And matter can change physically or it can change chemically. So by the end of this lesson, you should be able to take an example and identify whether that is a chemical or physical change, and you should be able to look at an illustration at the molecular level and identify whether it's a chemical or a physical change. So let's start out with just thinking about matter and what it's made out of. We learned before that matter is made of atoms and that it comes in different types. You can have elements, compounds, mixtures, and thinking about what matter is a big part of whether something is a chemical or a physical change. So let's take, for example, say we had some water. It's a substance that everyone is pretty darn familiar with. So if you've got a glass of water here, most people know that water is a compound and it's made out of two different elements. It's each little molecule of water is made up of one atom of oxygen and two atoms of hydrogen. And these little molecules are the little pieces that make up the liquid or the solid or the gas that we call water. So what's interesting is if you have pure water, you really can't do anything to it to separate parts out of it. You can't really do a whole lot and get different parts out of water physically. But you can do some things to water to actually get this molecule to come apart. So sometimes, like for example, if you run electricity through water, if you put a positive and a negative electrode into the water so that electricity can pass between them, the electricity will interact with the molecules and it'll actually break them up. And what you'll end up getting is, instead of having the water, the electricity breaks the water molecule apart and you end up with hydrogen molecules. So you end up with hydrogen, and you end up with oxygen molecules. So you end up with oxygen. So where you started off with water, H2O, after running electricity through it, you've actually ended up with two new substances. And that's the key that we're going to keep going back to here. You've got new substances. The substances that are new in this instance are hydrogen, which is H2, because there's two atoms in each molecule, and oxygen, which, if you think about what I just said about hydrogen, oxygen is O2, because there's two atoms of oxygen in each molecule. So there's definitely a change here. You've run electricity through the water and you're getting a change. Where you had water before, now you've got hydrogen and oxygen instead. And so the question is this a chemical or a physical change? What kind of change is it? And the key is that what we have done to the water, the way in which the water is changed, generated new substances. That's the key. Whenever you've got a new substance, then what has happened to the matter is a chemical change. Chemical change. So that's the key that you're always going to be thinking about, whether you're looking at a picture of molecules or whether you're just thinking about an example. You always have to ask yourself, is this change creating one or more new substances? And if the answer is yes, then that change is a chemical change. So you might be asking yourself, well, okay, if that's what a chemical change is, then how about a physical change? Well, we can stick with our water example, except instead of running electricity through water this time, let's think about adding energy to it in a different way. Let's think about heating our water. So now we've got our water here, and we're going to put it, let's say we put it on a hot plate, some kind of heat source. In the lab, we'd set it on a hot plate, and we'd turn the dial up, and the water would get hot. Here's a cord for the hot plate. The water would get hot, and everybody knows that once the water gets hot enough, it starts to evaporate, and then eventually, once it gets hot enough, it'll actually start to boil. And you'll get like bubbles forming in the water. And those bubbles will rise to the surface and break, and that's called boiling. So it's the same thing, same kind of change is happening. The water is changing from a liquid water to gas water up in the air. It's just the rate at which it happens is the difference between evaporation and boiling. So let's think about what's happening here. Before the change, before we put the water on the hot plate, we had water molecules. So again, it's an oxygen with 2 hydrogen, right? So that's what the substance is made out of. That's the particle of the substance, a water molecule. And then we heat up the water, and it turns from a liquid to a gas. And so the particle of the substance at that point is, guess what? Still a water molecule. It's just that now that it's a gas, the water molecules are moving much, much faster, and they're much, much further apart. So from this change, you basically have gone from water, that is a liquid, cursive L there, to water, that is a gas. We don't often think about water as a gas, but that's what humidity is and things like that. So you have to ask yourself our important question that we talked about earlier here. Is there a new substance? The substance before the change was water, H2O, and that was a liquid. And the substance after the change was water, H2O, except that this time it was a gas. So there is no new substance here. No new substance. The basic particle hasn't changed. So the substance hasn't changed. And so, as you could probably guess, this isn't a chemical change. This is a physical change. And that's basically really all that there is to chemical and physical changes. So now that we've kind of gone over the basics of what a chemical and a physical change is, let's just kind of think of some examples here. I'll scroll down and we'll kind of go over some examples. Some of them are really easy, like if I take a piece of paper and I cut it into a bunch of little pieces, right? We don't even have to get into the fancy, molecules for this one. The substance we had before was paper, and the substance that we have after is paper. So this would be a physical change. The substance has not changed, so it's a physical change. But if we took the paper and instead of cutting it up, let's say we lit it on fire. I light this paper on fire here. Yeah. Ooh. There's my flames. So we lit the paper on fire. If we light the paper on fire, then what do we have after the paper burns? Well, the first thing that kids usually think of is that you've got a pile of ashes. So they'll say, oh, you've got ash. And that is true. You do have one thing called ash. And ash is actually a mixture of a whole bunch of different kind of carbon compounds. Another thing that they don't realize is that whenever you burn anything, it also makes 2 other substances. One of them is the gas carbon dioxide, and the other one that it makes always whenever you burn anything, and this surprises most students, is water. It always makes water. So basically you've taken one substance that we call paper, and we've turned it into 3 new substances, a mixture that we call ash, carbon dioxide, a compound carbon dioxide, and the compound water. So obviously we've got one or more new substances here, so this is a chemical change. So let's think of, just off the cuff, a few more examples, and then maybe I'll leave you guys to work through on your own how they might possibly be physical and or chemical changes. Another physical change could be like if you took and you shattered a piece of glass. Another example of a physical change would be if you took some salt and dissolved it in water. So dissolving salt in water. That's another example. You still have water and salt when you dissolve salt in water. A melting ice cube. As a matter of fact, any kind of a state change is a physical change. Right, so those are some examples of physical changes. Now let's do some chemical change examples. A kind of classic chemical change example is rusting of like iron. When iron rusts, it's actually reacting with the oxygen in the air to make a new compound. And iron isn't the only metal that does this. There are many metals that will react with oxygen. We call it oxidizing, and so we call the rust oxidation. Another one that you probably have done, or I know you've seen, is if you mix vinegar and baking soda. So if you think about that one for a minute, you might be able to come up with the reason why you can know for a fact that when you mix vinegar and baking soda, it actually creates one or more new compounds. And I'll leave you to kind of think about that for a minute. One that a lot of students often are kind of surprised to hear is cooking an egg. Matter of fact, cooking anything, but we'll just use egg as an example. So when you start with the uncooked egg, you've got the clear white, and when you cook the egg, you can very clearly see that the white is somehow changing, and what's happening is that the proteins inside of that white slimy part of the egg are changing into new substances, and that's why it turns white and it goes opaque, you can't see through it, and why it also changes from that slimy liquid into a solid. So those are some examples of chemical changes. So there you have it. That's your online lesson for chemical and physical changes.